The exam, yes, I did grade it. The highest score was high 30s, and the lowest score was 14. So I'm going to go through and look at the exams and try to figure out what went wrong. And so they should be available to you probably this afternoon. But just there's the update. We're moving to a new topic. We're talking about earth science. Earth science is primarily geology, but we also will have some weather ideas here in earth science as well. Remember, we're doing physical science, and we had not just one area in science, but what are the areas in physical science? There's the fundamental science, physics, chemistry. Yeah, let's be careful with the astronomy, not astrology. And sometimes we say meteorology. I think our textbook just puts meteorology in with earth science. So here we're going into the third one. As you can tell just by looking at a calendar, the physics and chemistry, because they are so prevalent in everything, took up much more time than these other things. What we're going to study here in earth science is going to rely on things we learned in physics and chemistry. So start up with, what is the earth made of? We've just finished chemistry. We've talked about that periodic table. We've learned that there are 90 naturally occurring elements. Just 8 of them make up 98% of the Earth's mass. So you're like, wow. So we learned about all of these, and we talked about more than 8 elements, but there's only 8 that make up 98%. And then if you look at those, what's the dominant type of atom? Now, when you look at something like this, there are 2 ways of analyzing. You can do it by the number of atoms or by the mass. And it makes a big difference because it's going to take 58 or so hydrogen atoms to have the same mass as 1 iron atom. So you can see different percentages depending on if they're doing it by atom number or by mass. I'm pretty sure this is by mass. So which element makes up the most of the Earth? Iron. Iron is 1/3 of the Earth. Then we have oxygen is a little bit less than 1/3. So 2 elements make up roughly 2/3 of the Earth, just iron and oxygen. Hence, we should expect a lot of rust, because what's rust? Iron oxide. It's oxidized iron. Then we have silicon, 15.6%. Now, Silicon Valley is not a valley filled with silicon. It's a valley where they do a lot of things that use silicon. That is, working with computer chips, which are using semiconductors, and silicon is semiconductors. Then we have magnesium, and then we get down to trace things. Nickel is only 2%, calcium 1.8%, aluminum 1.5%, sodium 0.2%, others just the 1.9% remaining. So you look at this and you say, wait a minute, precious metals. Nickel's the only one that you might ever consider a precious metal on that list, right? Well, you consider nickel a precious metal because that's what we make nickels out of. Maybe copper, but yeah, copper's not on that list either. So, is copper plentiful or rare? It's going to be rare compared to the other elements, and yet it's reasonably plentiful. We have lots of copper around. Well, why? Because even though it's less than 1%, well, I don't know if it's actually less than 1%, but I think it is, of the Earth's total mass, the Earth has a pretty big mass. So there's still a reasonable amount of it. Gold, much less, platinum. So there's lots of elements you don't see much of. So the first thing here is just to understand what are the most common elements. And then we're going to learn why they're most common when we talk, I think, in astronomy. When we talk about the geosphere, we're talking about the solid part of the Earth. It's made up of rocks and minerals. So we have to identify what is a mineral. Anybody know what a mineral is? Go ahead, Deborah.
Different rocks mushed together.
Okay, well, actually, rocks are different minerals smushed together, usually. So minerals are actually the chemical compounds that form the rocks. And so we'll learn about a number of minerals here as we go through the earth science, and it's in today's lecture. Yes?
Do you have any potential test questions?
Do I have forms? Yes. So we've learned about floating. We learned that less dense things float, more dense things sink. So when we talk about the minerals and rocks, some rocks are more dense, some are less dense. And the less dense rocks float upward, the more dense rocks sink. It's kind of odd to think about that because we think about the earth as being just this solid thing, and things don't float or sink in solids, they float or sink in fluids. But the earth is actually pretty much a fluid. It's just a fluid that flows very, very slowly. Unless you have a landslide, then it might flow a little faster. And so you do have rocks that will float up and others that will sink down so that we have less dense things floating up. Where are we in terms of the earth? This is a dumb question. It's not a sophisticated one. In terms of the earth, where are we located? On the surface, which means we're the place where things that float are. So the things around us are going to be the less dense materials. The more dense things will have sunk down toward the center. So that list of the different elements and their composition of the earth, up here, we're going to have more of the less dense things, less of the more dense things. It turns out iron is a fairly dense thing, so we expect that the inner core, the center of the earth, is predominantly iron. Whereas up here near the top, we have a lot of silicates. And silicates is a thing that's going to come up in a moment. So let's talk about the earth. Here's a cutaway picture of the earth, noting the different pieces. The outermost part is the crust. So we are standing on the crust. Change pin. We're standing on the crust. The crust is what's just below us. Any actual thing that's ever been touched by a human is in the crust. There are things that come up to the surface that weren't in the crust before, but they made it to the crust before they reach us. We have tried and tried to drill down through the crust. The problem is, if you go down deeper, the temperatures go up. As the temperatures go up, you start to do things like melt your drills. And so there is, okay, so we broke another one, pull it out, let's put another one in. Okay, we got another, 100 feet and this one broke. Why are they breaking? Because they're getting hot and getting soft. So we've never been able to drill through the crust yet. How thick is the crust? Well, let's go back a step. How do we know that there is a bottom to the crust to begin with? How do we know what the inside of the earth is like if we've never penetrated this crust that we believe to be somewhere between 5 to 30 kilometers thick, depending where you are? How do we know that? Or do we know that?
It's a theory.
It's a theory. No one knows? The big answer comes from earthquakes. Earthquakes, both naturally occurring and some human-made. Anytime there's an atomic bomb detonation, we learn more about what's on the inside of our Earth. Anytime there's an earthquake, we learn more about what's on the inside of our Earth. Because there are waves that go through the Earth. And those waves going through the Earth can give us the same kind of information that waves going through your body can give you. Waves going through your body, depending on the waves, they'll go through better or worse. So I talked about going to the airport and going through, actually it wasn't this class, I think it's my other class where I talked about going to the airport and going through the little nudie scanner, right? The little thing where you stand up like
May
this.
I have your attention, please?
Sure.